Dear colleagues, POLY-CHAR friends and guests, greetings from Ukraine. I hope you have a good time in Auckland. Thank you for the possibility to present our latest results on creation and investigation of microporous cyanate ester resins using boron nitride. My last year presentation in Halle disclosed the fundamental possibility of obtaining of porous thermosetting cyanate ester resins using a thermal-nuclear reaction of hexagonal boron nitride induced by neutron radiation. We have developed the general procedure of pore creation using such approach. The present talk discloses the effect of BN concentration in the CER-based film materials on pore size and structure of the final film materials obtained. This work was performed in collaboration of two organizations from the National Academy of Sciences, namely Institute of Macromolecular Chemistry and Institute of Electron Physics, together with French East Paris Institute of Chemistry and Materials. As a basic polymer matrix in the present research, we use high-performance thermosetting cyanate ester resin. As a second component, hexagonal boron nitride was used. The main characteristics of both components are presented on the slide. On the first stage, we have prepared CER-based films from dicyanate ester of bisphenol E and boron nitride in the presence of catalyst through the high-temperature synthesis under the following theme. BN content in the cured samples was varied from 0 to 2 weight%. And then we have made NSEM investigations of the films produced to study the morphology of the films and to estimate the amount of BN component inside the initial films. Using EDX spectroscopy measurements, it was found the presence of boron and its content in the corresponding CER matrices. By the way, strong dependence of boron element inside the CER film produced on the initial amount of BN content was found. Generally, creation of porous structure in polymer materials using nuclear technologies involves the exposure of polymer film to irradiation of with high-energy particles and formation of tracks consisting of fragments of polymer macromolecules, followed by subsequent etching procedure, when these fragments are leaching out from the tracks leading to formation of pores. But in this, we have applied the well-known for nuclear physics effect of absorption of a thermal neutron by a boron atom, including the nuclear reaction inside the hexagonal boron nitride, as shown here. Irradiation of beam with neutron induces the nuclear reaction, creating lithium and alpha daughter particles with large kinetic energies. 94% of these alpha particles exist in the excited state. Thus, we assumed that these particles could provide generation of tracks inside the material, and subsequent track etching procedure could lead to formation of porous structure. Moreover, after generation of charge carrier by lithium and alpha particles, the collection of radiated generated electrons and holes occur. So we have developed and performed neutron irradiation procedure and track etching under the conditions presented on the slide. CM investigations fulfilled after irradiation but before etching showed that neutron irradiation applied had no effect on the neat matrix morphology, and that morphology of the irradiated Serbian films investigated appeared to be similar to that of the neat matrix. And no porous structure after neutron irradiation of BN-containing CERs was observed. FTIR measurements showed that even at 2% of BN in the initial composition brings no significant changes into the chemical structure of the samples, obtained at all the stages of pore generation. To confirm the stability of the bulk CER matrix to irradiation and etching procedure, SEM measurements of CER as for reference sample were made. And as you can see here, the neutron irradiation and etching procedure applied had no effect on the CER matrix morphology. At that, introducing of 0.1 weight% of BN into CER matrix results in formation of porous structure. It was also found that in this case, pore structure is formed. Further increase of the initial BN contact resulted in generation of much more developed pore structure. So the higher initial BN content revealed, the more well-defined pore dispersion and higher porosity of the films produced. The calculations performed using ImageG program have shown the presence of micro-sized porous structure with larger pore diameters ranging from 5 to 30 microns and numerous smaller pores inside having diameter size distribution from 0.2 to 2 microns. The mean pore diameter determined using Mercury porosimetry have shown the sizes of pores from 10 to 25 microns, but very low porosity values were defined. Such results can be obtained in case of the absence of interconnected porous structure and formation of isolated pores that is consistent with the SEM results. TGA studies have shown that thermal stability of the final microporous CERs appeared to be close to that for the NEAT matrix for all the samples investigated, with onset degradation temperatures higher than 400 degrees centigrade and maximal degradation temperature values around 440 degrees centigrade independently the initial BN contact. Thus, it can be concluded that novel approach for producing of porous polymer materials using boron nitride and nuclear technologies have been successfully developed and applied in creation of micro-sized porous CER-based materials. The effect of BN concentration on morphological peculiarities of the final CER-based film materials produced was established. Strong dependence of the initial CER-BN ratio on pore dispersion and porosity of the films produced was affirmed. It was found that the proposed pore generation technique has no significant effect on chemical structure and desired high thermal stability of the NEAT CER matrix. We gratefully acknowledge the French National Center of Scientific Research and National Academy of Sciences of Ukraine for the financial support through the French-Ukrainian International Associated Laboratory POLY-NanoPore and POLY-Thermat International Research Project. These complicated times when the world is changing, I hope that you stand with Ukraine.